Let's talk about the circle. I mean, just take a quick look around you right now. You'll probably spot one, right? Maybe a clock, a wheel, the top of your mug. It's got to be one of the most basic shapes in the world, but it's hiding these incredibly elegant, powerful secrets, right in plain sight. Today, we're going to decode that secret language. So let's just jump right in with a little puzzle. Here we've got a circle. You see that line CD? That's a diameter, cutting right through the middle. And it's crossing another line AB, which we call a chord. Now, here's what we know. The chord AB is sliced perfectly in half at point E, so each side is 4 centimeters long. And we also know that tiny little piece, CE, is 3 centimeters.
So here's the big question. With just those numbers, is it even possible to figure out the radius of the whole circle? I know, at first glance, it really feels like we're missing some crucial information. But trust me on this, by the time we're done here, you'll see how a few simple secrets make the solution just click into place.
Okay, so to crack this puzzle, we've got to learn to speak the circle's language. Let's build our toolkit, starting with the absolute basics. You know, the fundamentals.
Everything, and I mean absolutely everything, begins right here, at the center. You can think of it as the heart of the circle, its anchor point. Every single point on that perfectly smooth outer edge is the exact same distance from this one spot.
So from that center point, 3 really important lines emerge, and their relationship to that center point is what defines them. Let's take a look.
First up, the radius. It's just a straight line from the center out to any point on the edge. This distance is kind of like the circle's DNA. It's the fundamental building block. And what's crucial is that every radius in the same circle is the exact same length. No exceptions.
Next, we have the chord. All a chord is a straight line that connects any 2 points on the circle's edge. You can draw them super short or really long. In fact, you could spend all day just drawing an infinite number of different chords inside any circle.
And that brings us to the most famous chord of them all, the diameter. It's the king of chords, right? And what makes it so special is that it's the one and only chord that has to pass right through the center. That also makes it the longest chord you could possibly draw. So here's the key takeaway. A diameter is really just 2 radii stuck together end to end. It's always exactly twice as long as the radius.
All right, now that we've got the vocabulary down, we can get to the really cool stuff. These are the core properties, the hidden logic of the circle, what I like to call the secret rules that control how all these parts work together.
Okay, this first rule, this is the big one. It is incredibly powerful, and it is the main key that is going to unlock that puzzle we started with. It's all about this really simple but amazing relationship between the center, the middle of a chord, and a right angle.
And this picture shows it perfectly. So check this out. If you draw a line from the center, that's point O, and you hit the exact midpoint of any chord, in this case, point C on chord AB, bam! It will always form a perfect 90-degree angle, every single time. It's a rule. And what's so great about this is it's not a one-way street. It works in reverse, too. So if you draw a line from the center that hits a chord at a perfect 90-degree angle, you know for a fact that you've just sliced that chord into 2 perfectly equal halves. It's a 2-way geometric guarantee, and that's what makes it such a powerful tool.
Okay, on to our second secret rule, and this one is all about the beautiful, perfect symmetry of the circle. The rule is just elegantly simple. If chords have the same length, they have to be the same distance from the center. This diagram says it all. If that chord AB has the exact same length as chord CD, then their perpendicular distance from the center, that's OP and OQ here, must also be equal. The circle is just perfectly balanced. It treats equal chords equally.
Okay, our toolkit is assembled, we understand the rules, now we have everything we need. It's time to go back to the beginning and crack that mystery wide open.
Remember this? With what we know now, this picture should look a little different. We were told the diameter cuts the chord AB right at its midpoint, E. And our secret rules tell us that when a line from the center hits the midpoint of a chord, something very important happens.
So, here's our game plan, broken down into 3 simple steps. Step 1, we apply secret rule number 1. Since that line from the center bisects the chord, the angle at E has to be 90 degrees, no question. Step 2, now look at what that right angle just created for us. If we draw a line from the center O to point B, we've got a perfect right-angled triangle, OEB. It was hiding there in plain sight the whole time. And step 3, whenever you see a right-angled triangle, what's the first thing you should think of? Yep, the good old Pythagorean theorem. All right, so let's put some labels on our new triangle.
We know one side, EB, is 4. The hypotenuse, the long side opposite the right angle, is the line OB. Well, that line goes from the center to the edge, so its length is simply the radius. Let's call it R. Now for that last side, OE. Well, the whole distance from the center O to the edge at C is also a radius, R. And since we know that little piece, CE, is 3, the length of OE must be R minus 3. And just like that, we have our equation, R squared equals, open parentheses, R minus 3, close parentheses, squared, plus 4 squared.
Now, when you work out the algebra, something really neat happens. The R squared terms actually cancel each other out, leaving a really simple calculation. And what does it give us? A precise, beautiful answer. The radius of the circle is exactly 4 1/6 centimeters. A problem that looked impossible just a few minutes ago, it just melts away once you know the rules. So satisfying.
So, that was a fun little puzzle, but why does any of this actually matter? Because these simple, elegant rules aren't just for geometry class. They are the invisible blueprint for, well, for so much of our world. Seriously, think about it. The gears in an engine have to be perfect for a car to even run. The magnificent domes on ancient buildings, they're still standing because the architects understood this geometry perfectly. How do astronomers track planets moving millions of miles away? They use these exact same principles. Even the smooth animation in your favorite movie is built on algorithms that are all about the properties of the circle. This stuff is the invisible code that makes our world work. So the next time you see a circle, don't just see a shape. Remember the hidden logic, the secret rules of centers and midpoints and right angles that give it its perfect form and its quiet power. And it kind of leaves you with this thought, right? The circle is this perfect, complex system, but it's governed by just a handful of simple rules. It really makes you wonder what other complex systems in our world might be hiding a similarly elegant logic, just waiting for us to discover it.